So if you get a function where you know its behavior, like a rational function, it usually has some vertical asymptotes like this. But if you know the behavior isn't crazy, it doesn't like start acting like a piecewise function, you can usually just plug in the limit to evaluate the limit. If you have a divide by zero error, then there's some problems you got to rewrite. But this one, the limit as x approaches -3, there's no chance of a divide by zero error, and I don't think if we, it won't factor be a perfect square. So we can evaluate this limit by just plugging in -3. Kind of feels like cheating because we're in calculus, but all we're doing is we're plugging and chugging, plugging in a value and chugging out the result. I hope plugging and chugging doesn't mean something bad. I'm not hip, so it probably does. So that's -81 in the numerator. -5 times -3 makes +15. And then we got 2. -3 is being squared, so that makes 9. So we still have a minus sign there. So in the denominator, I get -7. 15 plus 7, subtract 81. I got -59/7. I don't think that's what Newton got. Yeah, I was going too quick there. -3 to the third power is -27. -27 times -3 makes a +81. So this should be 103. 103 over -7. So, and the reason why you can do that is because of the properties of limits. This is the same thing, and this will come in handy later on. It's the same as -3 limit x approaches -3 to the third power minus 5, and then for x it's the limit as x approaches -3 plus 7. You can replace every x with that limit, and that's a nifty property for limits. Helps us evaluate some complicated things later on in calc. But okay, this one they say that the limit as x approaches -6 if f(x) is 3. They don't tell us what f of x is, but they tell us what a limit is. So we get to use our limit properties again. The limit operator is, well, I don't know, is it an operator? The limit behaves as a linear operator. In other words, it means that the limit can distribute. So I distributed it to the first term. And I distribute it to the second term. And now that we've done that, we know what this is. The limit as x approaches -6 of f of x. That's 3. So we got a -3 plus 3 times whatever this limit is. That's -7. So again, if it feels like you're cheating because it's too easy, you're doing it right. These ones aren't too difficult. Okay, it's just practicing that limit notation.